an office making a presentation in, I think it's almost 2 years now. So I'm kind of excited to be here. It's great to actually look at it. I have like this is not a fake background. It's actually a real place. And Cockroach Labs has actually moved offices since last time I provided a webinar. So this is our newer office. So really excited to be here. And thanks everybody for joining us. Tim, do you want to join me?
I do want to join you.
Hi, buddy. I'm still looking at you in your basement, and that's good. But one day you'll be up here.
Hey, one day is actually coming sooner than later. I'm actually going to be in New York, my first visit to this brand new office next week. So I
that's
am
great.
personally very, very excited to leave the confines of the
Well,
basement
that's
for
cool.
sure.
Hopefully I see you next week. It'd be nice to actually see people, y'all. So this is my friend Tim Vale, everybody. Tim, thanks for joining us today. Tim leads our solutions engineering group. He is a practitioner in all things data and database, and you code in a couple different languages as well, right, Tim?
I do. I try to write as much software as possible. It's the only thing that really keeps me sane these days. Probably shouldn't admit that publicly, but it's true.
Yeah, I don't code anymore. I just talk. Like I have this title called evangelist, so it's basically I just go out and talk. So, but Tim and I both come from a bit of a technical background in all these things. So as with anything in any of these sessions, by all means, please ask questions, drill into items that if they aren't clear, if they need clarification, please by all means do. This is cool stuff. This is kind of an intermediate session. I always like to start things by just saying I'm super curious about tech, and I think that some of the things that we're going to talk about here are the concepts that kind of are going to define our futures for everybody over the next, not this year alone, but like the next 5 to 10 to 15 years. I feel there's a sea change in the way that we think about things going on, and today we're going to talk about sharding and how you scale a database, and some of the reasons why people, why we've changed the way we think about these things. And so that's the concept for today. So I'm going to go through about 10 minutes, 15 minutes or so of material, and then I'm going to turn it over to Tim, and he's going to do a demo, and we'll show you some hands-on keyboard time. And we're going to come back, and I'm going to explore kind of how it works under the covers, like what Tim did, and kind of some of the using graphics basically to explain kind of how that works and what we're doing under the covers. And hopefully this will allow you and provide insight into the way that you think about your own applications and how you scale them. We think we have a database that fits that world, but I think also as we build these kind of complex microservices and kind of these distributed systems, some of the principles here should definitely apply to the way that we think about architecting and developing our own software. And so that's our goal today. So anything else to add, Tim, before I jump into the world of sharding?
No, this is an exciting topic, and I am prepared to do a demo. I wasn't
Great.
2 minutes ago,
You're
but I am
prepared.
right now, so we can do it.
This is why I do these things with you. You're always prepared, dude. You're like the Boy Scout.
We're ready.
The Boy Scout of Cockroach Labs. Anyway, so all right, everybody. So first of all, why do we scale databases? Data volumes grow. I think that's what people typically think about. Transactional volumes grow as well. And I think that's something that we don't always think about because we haven't had to think about that in many cases. But it's actually a really, really important piece. And I think the third part, which I like to talk a lot about, is we don't just scale up the database, right? We actually can scale out. And geographic scale is becoming more and more important in many businesses. As the business world shrinks to wherever you are today. I'm in Manhattan, Tim's in Atlanta, I'm sure we have people on from different parts of the world. I saw South Florida, Massachusetts. Where are your customers and what does it mean to service them? What are their SLAs? What are they expecting? Because I tell you what, it's really easy for people to just up and move to a corresponding service if they don't get the interaction they want, or if you lose their data, or transactions, things just take too long, right? And so geography actually becomes really important. Another one we're going to talk a little bit about it in Tim's demo is we start to think about resilience. And what is it? Geographic scale becomes very important. Can we survive the failure of an entire AZ and when we deploy? Better yet, a region. What about an entire cloud provider? Can I fail if, like, let's say, one of the big three went down? Can you survive that? Will your customers still be serviced? And thinking about failure domains in the context of scale is actually a pretty important concept these days as well. Because I think, we'll talk a little bit about how the active passive systems and the days of old are not kind of resilient to kind of the modern expectations of consumers. And so that's just kind of to set up the conversation. So when we think about scale, I always think kind of three ways in which we used to scale databases, right? Number one was, well, there's this vertical scale, right? Like I have this database running, I increase the size of the machine, and I'm going to get more throughput. I'm going to get larger memory. I can get more storage. Like I'm just going to get better performance out of that. Like this is what I used to do back in the late 90s when I was deploying an app. It was like, great, okay, go out, figure out how many records you're going to have. Go to the big database provider, it was Oracle or Sybase back then. Figure out what your license cost was. And then after that, go out and buy the biggest damn machine you possibly could with the rest of your money. And that's what you're going to get, right? Like, and that's what the equation kind of used to be. Today it's a little bit different. We just spin up on a different, EC2 instance, or, choose a different instance type in the database and that sort of thing. But typically it's like the machine type is what kind of depicts how we're going to scale. That's kind of that vertical side, right? Again, there's an upper limit here. All physical items have an upper limit, right? And this doesn't really allow for any geographic scale. We'll get into that in a second, right? Horizontal scale is something that we actually came up with over the past 20 years as well, where it's like, maybe I just have two instances of the database and I'm going to synchronize the data, and I'm going to have one node where it's doing, or one instance where all my writes are going to it. And I have kind of followers, if you will, that I'm synchronizing to where reads are happening, right? And so you kind of have this primary, everybody's servicing reads, lots of issues here, right? You're still limited in scale for your transactional volume, your writes, right? Synchronization can get out of sync. You could have delays. You have the wrong data being read. You have dirty reads. Like there's a lot of different data issues that can happen here. And ultimately, I think the biggest problem here is like the maintenance of this is painful. Painful. What happens when something does go down and I bring something back on? Like if my secondary comes down and I come back, right? Like the mitigation of the differences between the two instances. Maybe one failed over to become the right node for a while, and like there's just so many nightmares here. And I think this works for some situations, not for all workloads. I think what we did as developers, as smart people, we thought of different ways, and one of those different ways was sharding a database, right? And so it's really creating kind of another instance of the database where I'm kind of segmenting where data records are going to be. Say I have a customer table, A through H is on one instance, J through Q is on another, and then the remaining is on the third. And in all instances, they're all basically accepting reads and writes, but it's up to the application logic to determine which instance of the database I'm actually going to. So there's a lot of different challenges here, right? So sharding a database is kind of one of these things. This is how I think this is kind of the most state-of-the-art way of people doing it. I think that's what people are doing. Typically, it's a manual process. I think there's a couple of solutions that have come out over the past like 2 or 3 years that kind of automate this sharding process. I know Citus Data was one of those things. They got bought by Microsoft a couple of years ago. I know the Vitesse project does this as well. It's like, how do I shard a MySQL database and leave the sharding part of it to be automated? Well, it's going to work, but it's only going to work maybe in a single region. You're still going to be limited in the types of transactions you can do, or when you start thinking about joins and some of these other things. And I'm not talking about particular solutions. It's just, there's still going to be limits to the way that you actually interact with these things. It may take some of the manual issues out of the coding, right? But typically in a database, what we're going to do is we're going to split the database in 2 or 3, 4, 5, 15. In the case of Facebook Messenger, I think it's 120 shards. Like that's incredible. Like, how do you maintain that? The amount of people it takes to just maintain that alone is just really, truly tremendous. Another way in which we do this, we typically think of like, how do we find data in these things? We'll use things like shard keys. And basically what we're doing is we're just kind of applying a hash function across a piece of data so that we can actually find these shards. This is a typically better way of doing things, because if you think about, like, if I just took a customer table and I said all records A to J are in one, I don't know, K to Q are in another, like you can get hot ranges, right? It really depends on that primary key. So like using hash functions in these things kind of have a more even distribution of data across shards. And that's kind of one of these things that we have kind of, figured out in terms of one of the challenges of these sharding of a database, right? And we actually use that in Cockroach a fair amount. We automate and like to another level. But that's kind of what some of the problems, right? So I always think of the challenges that developers have. Complicated SQL logic to handle sharding is error prone at best. different best practices, different, people are people, everybody codes differently, right? What happens upon schema modification? What do you're doing this across multiple different shards? Think about backup and restore. Think about bringing that thing up and bringing it back down. How do you roll those sort of things out? And really, it just kind of introduces risk. But I think the operational challenges of sharding are just truly tremendous. And what happens when a failure happens with one of your shards? You have this secondary backup system, and say there's complex joins going across all the different shards, or even just a massive amount. I mean, the ripple effect across other parts of the database actually are pretty incredible. Backups of shards. What are we doing in that adds complexity, right? So n+1 adds exponential complexity when you start thinking about backing up, right? The failover architecture is needed to implement sharding. Again, it's just the amount that the license and machine costs alone are expensive, let alone the operational costs and the people it takes to actually deal with these sort of things. And then if you need to reshard database, I had 3 shards, I want to go to 4, I want to go to 5, I want to 6, like literally the code that has to change to actually accommodate that, the backend operational framework and things that you have to do, just massive, huge operational challenges across the board. So any comments on that, Tim? I know you've been through this process before. Anything else to add?
Well, I think you covered it. I mean, it's one thing to kind of talk about it in this context and, kind of on slides in a vacuum. But, when we're out there working with customers, I mean, this is the real pain, right? I mean, these are people are really, really struggling with these things. And, given that all the pressures that are out there on, operational teams, developers, infrastructure, when you have this level of complexity in the things that you're managing, it can be really tough, particularly when things go sideways, and they do, right? I mean, they go sideways in a hurry. And so I think
they always do.
One of the things that that we've been lucky enough to have here at Cockroach is that you kind of gain all that you were attempting to gain with these sharding strategies, which were very much a necessity, for a long time. But you lose a lot of that operational complexity for all the reasons that you've mentioned, right? Mm-hmm. And all that's great when things are going well, but when things aren't going well, that simplification, that simpler infrastructure, that simpler deployment model, that simpler code that you have to write actually pays huge dividends. And that's what we're seeing. People just getting very frustrated with the level of complexity in these systems that they had to shard in order to scale.
I'm sorry, Tim. I got an itchy trigger finger on slides here. But I agree with you, Tim. And it's again, I think this is just one of those things. Once you see this, you can't unsee it. Once you don't have to do this, like like you don't want to go back. Like right. Like
you don't want to go do this if you don't have to.
Right. Exactly. Nobody really wants to shard a database. Nobody really wants to do active, passive, failover, primary, secondary. It's just, and I think that's one of those things. It's once there's another way, go for it, right? And just I think you don't go back. So at least that's what I'm saying. So the unobvious cost of sharding comes back to this, like we're saying, decreased productivity, increased costs, and really just added risk. It's make money, save money, avoid risk, right? Like just a traditional thing. And I think if we think about anything that we're doing in any of our applications or any of these kind of systems where we're changing them, how do those 3 things kind of apply to what you're doing? Can I increase my productivity because I don't have to focus on dealing with all this craziness, like Tim is saying, when something does go wrong? Great, like I focus on something else. I think we had my friend Sean from DoorDash, we were talking on a webinar one day, and I was asking him about, Sean, how much does it cost you though? Like, what's the effect on your team of like when there's downtime in the middle of the night? And he's like, are you kidding me? The middle of the night, that's easy. It's downtime in the middle of the day that's a nightmare. And he's right. You know what I mean? And like having something that's resilient and scales easily and all those sort of things kind of help those teams. And it's not just always a hard monetary cost. Sometimes it's the physical impact on your team, and the mental impact is also often not to be kind of, avoided or looked past, I think. So I'm just going to go through Cockroach and how we do this. I want Tim to actually show a little bit of, hands-on keyboard time. So, Cockroach, first of all, is a node-based database. This is a distributed database. This is familiar SQL. We are wire compatible with Postgres. We've done a lot of work in our database to make sure that we are. But this is a relational database. So the way you would think about normalization and referential integrity, secondary indexes, you want joins and aggregate views. This isn't NoSQL where you're kind of kludging those things or trying to make those things sort of happen. All the power of a relational database. And we're going to give you serializable isolate. We're going to guarantee data is correct no matter what. We're going to eliminate a lot of those kind of those data issues that can actually happen. Scaling Cockroach is actually pretty simple. You simply spin up another node, point it at the cluster, and the cluster basically deals with this kind of redistribution of all the data. And we're going to show you that in Tim's demo, and I'll come back and show you how this works underneath the covers in terms of what we've done technically in the architecture of the database to make that happen. Right. So if I just want to scale, I just start adding nodes, and I instantly have more read and write capacity and more storage, right? Because each node has its own, compute and storage associated to it. Now we can scale within a single AZ very elegantly. And I think that's really wonderful. We're still getting huge, massive benefits and gains, but I think we're often known as this database that scale across multiple different regions and geographically as well, which actually is pretty difficult to do when you start thinking about kind of these monolithic legacy databases. But there's lots of magic that we do within Cockroach to allow for this, including the feature that we have called geopartitioning. It allows you to kind of tie data to a location, which is and I'll come back and I'll show you how that works underneath the covers within Cockroach and the architecture as well. But scaling across a region is actually a pretty big important thing. I mean, it happens. I tell you what, like a construction crew can take a backhoe and take out a cable and an entire data center goes down. Is your application surviving that sort of thing? Do you need to? What kind of things can you put in place? And I think people use this from a resilience point of view. More importantly, do I need fast access to data? Can I put data in certain locations so I can actually scale geographically as well, right? We can even actually scale across cloud providers. We can have a single logical database that scales across multiple different cloud providers. I'm going to actually have our friends, we have a customer called Forum3 in the UK who actually has instance of Cockroach. It's running physically, one instance, one database running across the 3 different cloud providers. We're going to actually talk through their implementation details. I think it's like a week or 2 from now, but really, really, truly phenomenal stuff. So that's me talking. I talked for, what was that, Tim? Oh, it was a lot longer than I wanted. I'm sorry, buddy. What do you say, demo, buddy?
I say we do it.
All right.
I say we do it. And even while you've been talking, my approach to the demo has changed.
Oh, great. I love that.
I'm not sure it's great, but we're going to do a couple different things. So I thought maybe what we'd start, I guess it would make sense to show the screen, would it not? It would, wouldn't it?
That's usually a good start to a demo.
Yeah. So let me do that. Hold on just a moment, please. Okay, where are we? We're going to share my screen. Here I am. Can you see me?
Yep, we sure can, Tim.
Perfect. So maybe just a little quick background of what I'm going to show today. So we've been talking about sharding, and we'll tie all of this together, but there's some really interesting kind of things within the Cockroach binary itself that I wanted to draw your attention to, and then I can, if time permitting, show you a couple other things. So for those of you who want to just play around like uber quickly, even before, requesting a trial license or spinning up serverless, just want to understand kind of some of the mechanics of Cockroach and explore in a really easy way. The Cockroach binary, we only have one binary, and that's what you use to install and deploy regardless of scale. But the Cockroach binary itself has a command called demo. And what Cockroach demo does in this particular case spins up just an in-memory cluster with whatever kind of configuration that you want. And so I thought I would do that very quickly because I just wanted to highlight in a simple way some of the kind of the built-in features or capabilities of Cockroach. There are more sophisticated ways to do this, of course, where we could do something in Docker Compose, which I also have running, or some other things. But I thought this might be just a nice way. And I wanted to, for those of you who may be interested in playing along at home, go check out this particular page, Cockroach, go download the binary, run demo. What I'm going to do, and I already have done, is run the Cockroach demo command in a way to simulate, and you can see it down here, simulate a multi-region deployment or demo locality, right? Where we're spinning up and we're putting data in multiple places. And so I've already run this command, Cockroach demo locality, and what I'm showing you here, or not here, actually over here, is the Cockroach interface, where we have 3 nodes, in this particular case running under this demo command, but I have 3 nodes that are pretending, if you will, to exist in three different localities or three different AZs within Cockroach. And this gets back to, again, the concepts of sharding that we've been talking about. Cockroach by default handles this kind of data replication and clustering for you. In other words, sharding. So in this particular demonstration, we have a database that's already been created. This database is kind of our sample data set called Mover. And just like you would with a traditional Postgres instance or some other monolithic system, you have the ability to visualize or see the tables or databases that are stored. But in Cockroach, things are very different, right? Instead of it sitting in just one place, Cockroach is by default going to essentially shard or distribute this data around the cluster for you. And that can be seen in a couple different ways via the interface. But one of the first and easiest ways to see is, okay, I've got 3 nodes in my cluster. You can see them listed here. And if I expand out some of the details, you can see how long each particular node has been up. And if I drill back into the databases, you can see that, in fact, this data or the range, that's kind of what we would call kind of what is similar to a shard. Those ranges are distributed across the cluster. And I haven't had to do anything special. I've literally just created a database. I've just simply inserted data into the database, and Cockroach behind the scenes is responsible for taking this data, dividing it up into ranges, if you will, and spreading that data around. And then, of course, if I'm even more curious, I can look at all the wonderful kind of built-in metrics and data that Cockroach surfaces for you. I can get a visibility into what SQL statements are executing, how many replicas, how many copies of the data exist on each node. In this particular case, you can see I have 3 nodes. There's 73 replicas, if you will, on each node. So again, I haven't had to do a lot of manual configuration. All I've done is spin up 3 nodes, generated some workload on it, and I can see that within Cockroach. Haven't had to do a lot of manual orchestration or operation of the kind of the typical sharding type things that you would have to do here. So I'll pause there. I'd say,
Is there any
this makes
yeah,
sense.
there was, yeah, it's totally me. And is there any machine or memory requirements to run Cockroach demo that you're aware of?
Let's look at the docs. So I'm doing this on my Mac. I don't have a super powerful Mac. So no, I don't think, look, I think if you've got a reasonably modern machine, Cockroach demo is a wonderful way to just kind of explore the features and capabilities, certainly the interface. And it's a great way to have the kind of conversation we're having today, right? I don't have to go through this lengthy exercise of requisitioning hardware if that's my environment. And I can sit here and start to kind of understand the fundamentals of how Cockroach works by simply kind of browsing an in-memory version of it.
Yeah, Tim, I just put a link to the install for CockroachDB. Using Homebrew or whatever you want to do. It's pretty straightforward. Exactly. So easy a marketing guy can do it, I'm telling you.
Yep. And I'll just real quickly. So is this the only way to run Cockroach? No, absolutely not. And there are some other things, and I'll share a link here maybe when I'm off screen or if off sharing. But if for example you want something that's a little bit closer to kind of production, and you're familiar, for example, with something like Docker or Docker Compose, we have plenty of examples that I can share where, hey, I want to spin up a 3-node cluster using Docker Compose, and I want to simulate a workload on Docker and begin to kind of understand or tease apart how sharding or other core concepts in Cockroach work. That's something that can be very easily done as well. But I brought up Cockroach demo just because it's such a lightweight and easy way, and as our documentation suggests, there's lots of little things that you can do. You can run different kinds of workloads in demo. So we support things like TPC-C, right? So if you want to see a different kind of data set running different kinds of behavior, you can do that very, very easily.
And then Tim, there was a question about because we're with Cockroach demo and with the install, there's an hour thing. There's an hour of using the enterprise license. Enterprise license includes, distributed CDC, some of the more advanced security features. They're not really items that you're gonna, actually everything that's on this page, you're gonna be able to still demo. It's just that there's advanced features that we provide in enterprise as well, right?
Yeah, that's right. So the way it kind of works is that Each instance of Cockroach demos, it says here, kind of temporarily loads in an enterprise license. So what we
Right.
want you to be able to do is get the full experience of what Cockroach has to offer in a really fast and easy way to deploy in memory in this particular case. And so you get to see and play with kind of the full features, understand what they look like, how they behave. And then, yeah, that kind of goes away after an hour. And obviously we can support you to have a more permanent trial view. But this is a great way to start to kind of playing around.
And by the way, I'm sure if you just reach out to us, we are happy to provide you with a 30-day
We are.
license. And
We
yeah,
are
so
very
it's
happy.
lots. And actually, you can go out and use CockroachDB Cloud. There's lots of different ways to experience Cockroach.
Lots of
We
ways.
really want people to get hands on keyboards and experience with it. So reach out. We're happy to help.
Indeed. So that was kind of it, Jim. The other thing that we could do when my Docker Compose kind of system starts to load is maybe we can come back toward the end and do some failure scenarios,
Yeah.
where we kill some nodes and see. But the idea here, I'll just kind of talk to it maybe for a second, then we'll jump back in. Is the idea is, again, the beauty of Cockroach, the beauty of doing all of this kind of automatic data distribution and sharding is that we are resilient to failure. And so what would happen is, I've spun this data up, I've inserted a bunch of data, it's been distributed around the cluster. I have a 3-node cluster running. I can remove a node, and to the end user, right, nothing has happened, nothing scary, nothing bad. That the Cockroach continues to serve reads and writes uninterrupted because we're this distributed system, because data is spread across the cluster, because we're resilient. You can do that quite easily.
So while that's all starting up, Tim, I'll give about another 10, 15 minutes just on what's going on underneath the covers. So do you want to give me the screen back and I'll go through that? Great. Thank you, buddy. So can you see my screen, Tim? Oops.
Yep, I can.
I'm telling you, this thing has an itchy trigger finger today. It's really weird. Okay, so that was we'll come back to the demo. Actually, Tim, I'm going to go through, the slides that I do, and we'll come back. I think you know what we do. So, okay, so great. We'll come back to this at the end. So some of the things I'm going to talk through is distributed consensus. This isn't synchronization of data, number one. And we're going to talk about that. We're going to talk about Raft. We'll talk about how that kind of works. Tim mentioned this as well. Every node in Cockroach is an endpoint, which means every node can serve as both reads and writes. And we're going to write data to a cluster 3 times, 5 times, 7 times, some odd, I almost said even, Tim, some odd number of times. And you can have like 100 nodes. And if data is written 3 times, well, which 3 nodes is that on? I don't know. Like every node can find that data no matter where it's at within the cluster, which is actually a really, really important point, right? So every node is this kind of consistent gateway to the entirety of the database. Every node is the same binary. You don't have to scale differently based on what the things are, right? And it's kind of another one of those things, like this demo thing can be run on any node. Like we have a UI for the database. You can hit any node and you're going to get the same exact UI. So it's one single binary. And then we'll talk a little bit about geo-partitioning and how we can control where data lives within a cluster, right? So say I had 100 nodes and I had 30 in the US West. I had, 35 in the US East, and I had another, what's my number here, Tim? 35, 35. Yeah, 35. Yeah, 35. I had 35 over in Europe. Can I control which data is living on those various different nodes? Yes, and we can do that. We do have a table and really down to at the row level, but it's defined in each table. It's kind of what not always thought about when we think about scale, but actually pretty important. So when we scale across, huge geographies, am I avoiding the egress cost of moving data from, say, Germany to the United States? Tell you what, it can get really expensive. Yet still have access to that on a single record, access point. Can you still? And so there's lots of things that we can do, and we'll talk a little bit how that works underneath the covers here. So, Cockroach ultimately, and Cockroach database is ultimately implemented as at the lowest layer, the storage layer, as a key value store. It's actually a database that's built on a database. We were built on something called RocksDB. We've actually re-architected that to be something called PebbleDB. We actually rewrote Rocks and Go, and it actually is kind of works very well with the way we're doing things. And so, ultimately underneath the covers, we expose things as just a relational database, but we're storing things using KV. And at the KV layer, we have these keys and we have values. And the key is very special in this context of Cockroach. really good blog post about choosing the right primary key with Cockroach database. It's a very wildly popular blog post for us. But these keys are actually pretty important because it's not just the key to the table and like kind of the relational world. What we're doing is we're taking the table, we're taking the index, we're taking the key for that thing and the column name, and we're saying that's the K and the KV, and then the value is the value of that particular column. Let me show you how this works. Actually, the best way to just show you how this works is just, it does start to make sense on how we can actually translate, relational to KV. And that's really where the magic happens. If we think about this table, we have a dog table, right? And we have a bunch of entries over here on the right-hand side that we want to have. The primary key is ID, and we have name and weight as various different columns. What we're going to do is we say, okay, let's just take this thing and translate it to KV. We're going to take the first record. It's actually going to be stored as two different KV pairs, two different tuples. All right, we're going to have, okay, the table name, the ID, the primary key, which is 34, and then the value of that particular column, which is name, it's going to be Carl. Weight, 10.1. Okay, Downey, 13.4. Name. And so what you're seeing is this huge kind of sorted KV table with all this data in it. Now, if I wanted to insert something, and I want to insert something with a primary key, right, with the ID of say 8.4, right, 84 or whatever, well, it's going to go right in between 7A and 9.4. In this ordering of all this data is really kind of where the magic in Cockroach happens, because this is how we're able to find data. And I'll show you how that works, right? And so again, right, big monolithic key space. And what we're doing is we're taking that key space and we're dividing it into these contiguous 512 megabit chunks. Now, I remember when I started, I think it was like, it was 256 for quite a while. We changed this to 512. We've actually figured out kind of, the right size of these ranges, and think about these things as kind of shards, right? We call them ranges, kind of automating how we actually split the database or the tables up into these smaller pieces. We've gotten really, really efficient the way that we move these things around in 512 megabit chunks. And that's really kind of this kind of the magic some of that the engineering the engineering team has done underneath. Now, these are big enough that we can gain by being able to insert and do some special things with them, split them up and do these things very, very quickly. Yet small enough so that we can move them very efficiently across the entire cluster, all the nodes, right? And we'll show you how that works, right? So, but if I'm going to automatically do this, if I'm going to take this huge, massive key space and divide it into these chunks, well, I need to find that data. So we have this kind of index structure that's actually within each of the nodes. It's in the table structure. You can actually go look at some of this data, but not to be used by anybody. This is not exposed to anything. You're just using relational. This index structure works very much like a B tree. So if you're familiar with that kind of how to code that, that's really kind of how this one works, right? And so it allows us to find the data, which range data might belong to, right? So let's just say I want to insert data. So I want to insert a record. I want to insert Sunny into this thing. I'm going to go through the index. I know it's in the red range. I'm going to go to the red range. Hey, you got space? Yes, great. Insert it. Wonderful. Go back. Acknowledge the transaction happened. Cool, great. Okay, so now I want to actually insert another record. Oops. I want to insert Rudy. It's going to go to that range. There's not enough space. So underneath the covers, what Cockroach is doing is it's going to split that range in two, right? It's going to say, great, take half and half and do this, add an item to the key, to the index. And now I basically expanded the database, and this expansion, the scale of the ranges has now just happened. So as I explode volume of data, right, I have these ranges actually being, and it's now being distributed across all the various different nodes in CockroachDB, right? So that is resilient. And so that's basically, we just basically taken care of the entire sharding process. I'm still asking for a record. Select Rudy from dogs. It's going to know where to find it. I don't need to know where it is or any of these things. It just knows that it's in that range, and every node can actually find it because of this index is actually located on every single node. I know where to find these things, right? So we're using something underneath the cover. It's called Raft to do this. Now, the way that I like to talk about Raft is, typically when we think about scale and moving some things around, we synchronize data from one place to the next. That's a people, I'm going to synchronize the whole database from one place to the next or something. We don't do that, actually. We gain consensus, right? So when you write data, we're actually gaining consensus. We're basically gaining quorum, so that like when I want to write data to this cluster, these nodes, say 100, I'm going to write it 3 times or 5 times or 7 or 9 or whatever your replication factor is. And there's different reasons to choose different replication factors. I won't go too deep into that, right? But there's reasons you would do that. So as long as 2 of 3 nodes acknowledge and say, hey, I'm good, I wrote that, I'm good. I have consensus because I have quorum. The majority of the participants have said, I got this. And the third one's just going to come along. Even if it has the wrong data, it's going to correct itself and say, no, I got to be right. And we're using something called Raft to do this. Raft is a distributed consensus protocol. There's another one called Paxos. Both of them are super interesting. I'll give you a link to actually go out. But as you get deeper into distributed systems, you go out and you code and you build your own applications. Understanding Raft is kind of one of these things I think is extremely valuable to every software engineer right now. Because like I said, I think distributed systems is basically the future of what we do, and understanding things like this and how it works is actually pretty important. So I talked through, it's an odd number of replicas. A Raft group is basically talking a lot. So this is the blue range, right? We had this this is Lady, Lula, Muddy, and Petey, right? We're going to write this data 3 times. So I have this range, and every time I write to that range, I'm going to try to write it in all 3 places. As long as 2 or 3 come back, I'm good. And we're doing that through something called a Raft leader. The Raft leader is a special member of the replica group, where we're basically saying, hey, Raft leader, take care of this for me within your group, okay? And just going out and making sure everything gets done. And the Raft leader kind of has this authoritative, up-to-date understanding of what's going on. It also allows us to kind of get this consistency, right? Because the Raft leader is going to make sure that I'm getting this atomic replication. The entire thing happened. Because sometimes transactions aren't within a single range. Sometimes they're hitting like 4, 5, 18 tables, right? That Raft leader is actually in charge of making sure that that transaction, no matter what's happening, the very initial point, everything's going to be good across, multiple different parts of the database. And that's really, really tricky. And so while Raft seems fairly simple to understand, coding Raft and actually making it work at scale, super complex. And I think this is where the devil is in the details around, distributed systems. I know, Ben Darnell is one of our founders here at Cockroach Labs, and Ben is arguably the smartest engineer I've ever met. I mean, I've met some pretty good ones. You remember Owen O'Malley, right, Tim? That guy was awesome. I remember Owen, he single-handedly recoded MapReduce in Java at one point, I think, or HDFS, I forget which one it was, back in the Hadoop days. He was like ridiculous. That guy actually, when the Mars rover went black on Mars at one point, or dark or whatever, and it couldn't communicate, they called him in. And I remember asking Owen, I'm like, hey, Owen, wow, you fixed the Mars rover. He's like, nah, I didn't fix the rover, man. I just fixed the scheduler. It was the best response ever. But Ben is like this layer, like that kind of engineer, like they just think in a different way. And Ben, I was talking about Raft one day, and he's like, look at Jim, Raft is pretty easy to code when you're in your undergrad studies. Doing it professionally in a system like this is just super complex because it's the amount of complexity and the corner cases that can go wrong. So when you're looking at these databases as well, remember the maturity of the system itself is actually pretty damn important. Because there's a lot of weird things that can happen when you're coding distributed systems, and that's for your own distributed systems as well. It may work in like 9 out of 10 of your cases, but you know what? And 10 might be right for you, but there's another 20 or 30 different things that could go wrong. And I think we see this all the time in the practical reality of people going out and doing these things with distributed systems. So, okay, I'm off my high horse, but I will give you a link. I've given this link to, I don't know, hundreds. Whoever has this website should pay me. I don't know, man. The secret lives of data.com. If you really want a great like graphical representation of how Raft works, this is really, really wonderful. Tim, I think we should find this guy and thank him one day. I think you use this too a lot right in the field, right? So, yeah. All right. So, okay, so great. Now I have these ranges, and I'm going to actually distribute them across nodes. So how do we actually get the scale, right? Here we have a 4-node cluster of Cockroach. And when we write these ranges to these nodes, we're basically just going to write it. I'm going to write the yellow 1 to 3 nodes. I'm going to write the blue 1 to 3. I'm going to write the, so what we've done right now is we've actually distributed the data based on kind of even distribution across all the nodes, right? But I have diversity too. If one of these nodes go down, I still have 2 of 3 of the copies for any one of these ranges. So I'm going to be able to survive the failure of one of these node failures, right? And that's kind of one of this magic thing. And that's one of those things about scale. It's pretty important. We also do something, we do things around load. So let's just say there's a hot range, like the blue range is really popular because everybody loves the dog Muddy that's in the blue range, so we can actually isolate that on its own node so that we can actually increase performance. We're doing that underneath. There's a lot of heuristics and stuff going on underneath the covers. We do that. But often, people want to actually locate in different physical locations. So each node in Cockroach is given a name, basically, if you will. And at the table level, we can say, hey, look at all data that say, has, a country code of, I don't know, UK, that's going to live on, European servers. And at the row level, we can actually control that within Cockroach. Now, the way that we're doing is we're actually, remember this key I was talking about where it was like the table and the ID and the column name, that whole thing? We're just overloading that with another column. So when I sort, well, everything that had UK in that country code is together, right? Because there's this huge monolithic sort. And now all those ranges, all that data is together in that KVs. And all those ranges, well, we just know the ranges with that stuff, that all goes over there. And now we can geo-partition data, which to me, honestly, when I saw that in Cockroach, I just couldn't believe what was going on. It was like magic. But it's actually a really important part of scale, because when we start to scale across geographies, I think the biggest concern really is the egress cost, like stopping data from moving across massive, huge geographies. What if you're just synchronizing between one region and the next with, a traditional database, a primary and secondary? What's the cost of moving that data various different systems? We just selectively do that, right? You start to gain control over that, right? But more importantly, I mean, you start to think about backup and restore. You start thinking about compliance and regulations and these sort of things. It's actually scale is a bigger challenge than I think we actually know at the very beginning, or the reasons we do that. So that's kind of how it works underneath the covers. Tim, did you have more demo? Did you want to go through? What did you magically cook up in the last 10 minutes?
So I wanted to show just a couple more features about Cockroach Demo, because I think it's really important, and it's very useful for reinforcing the topics that you're discussing. Because I think, if you haven't played with this technology before and you're not familiar with these concepts, it can be sometimes kind of hard to wrap your head around them all. But Cockroach Demo, as do all the other mechanisms to consume Cockroach, provide you kind of an ability to really get your hands on it. So I'm going to go back to sharing my screen, and I'm going to go back to sharing what I had shared before. But there's a couple other little widgets that I thought would be interesting to walk through. And I know, nothing more exciting than looking at a command prompt, but I'm going to come back to the documentation and just call out a couple things. So, you can again, we have this binary, the Cockroach binary. You can run the demo command, but there's a whole bunch of other subcommands that you can add. Demo locality, which is what I'd originally started with, which is interesting. It shows it simulates nodes with different geographic regions, like Jim mentioned. There's also the ability to a quick shortcut for simulating a multi-region cluster, where you have basically 3 nodes in 3 regions. What does the cluster look like when that happens? Also, we talked a little bit about the placement of data for geo-partitioning. There's a quick flag to do geo-partition replicas, or to start a 9-node cluster with geo-partitioning applied to our sample mover database. So all of this you can kind of do with just a few commands in Cockroach Demo. But in addition to that, once it's up and running, you can start to simulate failure and simulate how, for example, data may or may not move around the cluster. And so you can do things like shut down a particular node, you can restart a node, you can add a region, you can decommission, you can recommission, all these wonderful things. So I thought I'd maybe just highlight that real quickly. I have this cluster up and running. I believe I did it with the geo-partition replica. So this simulates a 9-node cluster spread, I believe in this case, across 3 regions. So you can see our nodes here. If I switch over to our node map, what we're simulating here actually is correct. It's a 3-region cluster where we're simulating nodes in the US West, East, and in Europe. In addition to simulating just kind of where these things may exist on the map, we're actually simulating network latency that would be realistic given the location of those nodes. So one of the kind of the neat pages in the CockroachDB console for understanding how the network is behaving between nodes, because obviously network performance is important, is this network latency screen. And here you can see that we're kind of simulating what the round trip latency between certain nodes are. And this can be, again, this very useful tool. But anyway, I want to go back to the overview, because you can see here that I've got all of these nodes up and running. And we've talked a lot about replicas and ranges and data and where it lives, etc. You can see that roughly all of the nodes have kind of 85-ish copies of data or replicas of data. And what I'm going to do is I'm going to use one of these commands in the demo environment to shut down a node. I'm going to shut down, as I did before, node 3, shut down 3 and execute that command, and it's going to drain the node and shut it down. And so node 3 is now gone. And if we refresh this screen, actually probably didn't need to refresh it. It should have refreshed already, but you can see here now that one node is suspect or is in the process of draining. And although I don't think we're going to spend probably the time it takes to see this really fully happen, this is an interesting thing to try at home. What you would begin to see is that after a certain moment or after a certain period of time, this node would go from being suspect. Cockroach has identified something's wrong, but it isn't ready yet to say this node is completely dead, but ultimately it would say that. But what you would eventually see is that once this node dies, right, and goes away, Cockroach is going to automatically distribute, if you will, the replicas or the data that had been on this node to the other nodes in the system. And this is an interesting way to kind of understand how Cockroach is doing this kind of automated partitioning, automatic partitioning, resharding, whatever you want to call it. What you'd ultimately see if we just sat here and watched the kettle boil is that the numbers of replicas on the other nodes would start to increase, and obviously this would go down. And so it's, again, this kind of really interesting way to visualize and understand how Cockroach behind the scenes is treating data. Another interesting and maybe less graphical way of doing this is in our advanced debug section. So we've got all this, these pretty widgets and stuff that's easy to consume, but we have this advanced debug screen, which has something that, again, isn't super exciting to look at, but provides a lot of valuable information. And that's our data distribution and zone configs. And what you can see over here on the right, again, it's just in tabular format or table format, but you can see this cluster is made up of these 3 regions. And in each region there are this many AZs. And then this number that you see in this table are the copies of data or replicas for each one of those tables in each one of these nodes. And so again, what you would start to see over time is that this data has changed as this node is deemed to be dead and removed from the cluster. So lots of like observability and tooling that Cockroach provides in order to kind of understand the health and data movement. And there are even other things that we could show, but I just kind of wanted to, for a brief moment, show that. And again, highlight this idea that within the binary, without Cockroach Demo, or with Cockroach Demo, I can simulate some really complex behaviors, but I don't have to go out and worry about getting the infrastructure, getting my networking, all this stuff. It's a great way to like learn the basics, learn some of these core concepts before graduating to kind of, real infrastructure, if you will. So hopefully this was helpful. We could probably spend an entire hour alone going through Cockroach Demo, but I think this is a good way to kind of highlight some of the concepts you've been discussing.
Yeah, and it's unique, I think, to a piece of software. I've never seen this in a piece of software before. Have you, Tim, where there's like a whole demo system like this?
No, it's really fantastic. And we use it so much in the field when we're talking to customers and prospects, and customers we're finding love it too. Obviously, they're not running their real workloads here, but just, hey, you know what? Tell me let me help me understand how this works. Hey, go play with this for an hour and come back to me. And they're like, I totally get it now. It didn't make sense before, but now I get it because I can simulate these really complex deployments very, very quickly.
I think it's one of these things you kind of got a hands-on to actually experience it. Like I try to show you guys how it works architecturally in the background. You know what I mean? Like I'll do my best explanation to kind of give some of the basics of what's going on underneath the covers. But ultimately, this is there's 2 things here. There's distributed. There's lots of things that like Tim just went through. It's also just SQL. And so, you can go download the binary, CockroachDB, the core, and you can start to do all these different things locally. You could spin up an instance in CockroachDB dedicated, which is a fully managed cloud instance of CockroachDB where you're, I think we have trials for that as well. But there's also CockroachDB serverless, which if you just wanted to build a map against Cockroach and not worry about any of these things, we're pushing in that direction. That's free to use to just code against. If you're a developer who just wants to, place, it's like Postgres, but better. It's like a free version of Postgres, honestly, like single region for now. And we'll get, we'll expand to multiple regions. But I think it's one of those things, and that particular instance, we talk about scale and sharding right now in the context of Cockroach. Spin up a node, point it. That's elastic. Like getting to the point where you have this kind of like scale up and scale down based on your workload, that's a wholly other level. And I think the promise of really being able to address the scale problem from a serverless point of view, to me, is like the most interesting kind of vector of the entire database market is going to change over the next couple of years. So cool. Tim, there weren't a whole lot of questions along the way, but I do appreciate you jumping on and giving the demo. I did answer, I think, everything that was in the chat. So I don't know. Anything else, Tim? I'm always happy to talk to you, but
No, I
happy to
think
give
we're
you your
good.
8 minutes.
Yeah, no, I think what we're seeing here, so this node's kind of dying, right? It's dead, and we should start to see the kind of the behavior that that I had described. So
It's surviving.
yeah, I mean, and that's just it, right? Things are replicas are now under replicated. That's fine, but the cockroach is surviving. If this were a real system, we've lost a node, maybe unintentionally, maybe intentionally, but life goes on, and that's really kind of the beauty
Yep.
of Cockroach, but certainly the beauty of this demo environment is I can do this really, really easily.
So
So no,
Tim,
I think this was great. A lot of good information. These are complex topics, but again, the idea is we've kind of figured all that out for you. It just works with Cockroach.
yeah, hey Tim, really quick, there was a question here.
Hmm.
When you start talking about replicas in this context, what you're talking about the ranges, right?
Yeah, yeah. So that's right. So what we talk about in terms of replica is a copy of a range, right? So a range will be copied by default 3 times around the cluster. Each one of those copies, if you will, is what we refer to as a replica. I know there's so much terminology, and everybody has their own little different spin on it. But ranges and replicas, these are kind of Cockroach the terminology for some
Yeah,
familiar things.
some people call them shards. They call them
Yep.
tablets in systems. There's
Yep.
it's chunks of data of a larger table, and
Yep.
that's what the replicas are in this. So what we're down to 37 under replicated is this. So it's surviving, Tim.
Yeah.
It's getting back.
So all right. So again, what's kind of happening here is sort of neat. This node is essentially dying or dead, right? But I had said previously that what we're seeing is that most of the nodes had 85, right? But what you're seeing now, and it's a great call out, is that this number of under replicated ranges, meaning there were ranges that didn't have the requisite 3 copies that had dropped to 2, that number was higher. It's now lower. Why is it now lower? Because Cockroach is automatically copying or up replicating, making new copies of this data from the existing copies that it lived elsewhere in the system. And that's why you're starting to see a handful of these other nodes, their replica count is increasing. Why is that? Because it's gaining, or it's taking on additional copies that previously had lived in this other node. And ultimately what you would see over time is that this would kind of balance out. That this number would go back to 0, and that there would be even more of an even distribution of replicas across the cluster. And so, if you want to understand kind of how this all works, spend 30 minutes with Cockroach demo, kill a node, and kind of watch how this
Yep.
all unfolds. And you can see just while we're talking, it's these have increased from 97 or 90 to 97 or so, and that will continue until really
Yep.
this number goes to 0.
Tim, are there any TPC-C benchmarks that are available that compare this against other databases?
Well, it's a great question. TPC-C, for those who may not have the background, is kind of a well-known industry standard OLTP benchmark. We have spent, as Cockroach Labs, spent quite a bit of time testing. In fact, it's part of our nightly performance or test runs is an implementation of TPC-C. There are many implementations of TPC-C, by the way. Cockroach demo, the command that we've been showing, has a TPC-C workload built in, so you can actually do Cockroach demo with load TPC-C, and it will generate the required tables and actually generate a TPC-C workload. But that's not a good solution for comparing and contrasting with other technologies. if you're very interested in seeing how TPC-C runs across different vendors, that's a bit more challenging. There are some projects that attempt to do just that. One of them that comes to mind is Benchbase by the folks at Carnegie Mellon University, used to be called OLTP Bench. But that's kind of a database agnostic implementation of a number of benchmarks, including TPC-C. And so if you have interest in running it against other databases, you can. One final note about TPC-C, and then I will be quiet, is TPC-C is really designed to run at scale, very large scale. So running TPC-C, with a warehouse load of 3 or something small doesn't really highlight the benefits of scalable databases or distributed systems, truly distributed systems. So if you can run TPC-C at massive scale like we've done, and there's a lot of blogging about it out on our website, it's really interesting. Small scale TPC-C runs aren't quite as exciting.
Yeah. And, I always think about vendor published benchmarks as benchmarking. It's bull. Like it just, I'm sorry, but anybody vendor is going to publish the TPC's benchmarks and say compare us against something else. I'd find it to be, I don't know, it's finding a third party to do these sort of things, and a respectable, trusted third party is the critical thing with any sort of benchmarks. I think we're well past the speeds and feeds, database competition days of old. And these things are still important for sure. And we learn a lot every time we run TPC-C every night. And we learn from that, right? And so, but it's about us and how well are we performing. I appreciate comparing to other databases, Tim, but honestly, like, I'm no expert in the others. You know what I mean?
Yeah. Well,
Right.
and that's why what we often talk to people about is, we're happy to talk about some of these well-known benchmarks and happy to talk about how to run them and the tooling you might use to do so. But at the end of the day, what's most important to you, which by the way is ultimately the most important to us, is actually understanding your workload and what you really need to get out of the database and working to optimize that. That's where we'd love to spend our time, as opposed to running kind of more generic benchmarks. And generally, when we get involved, you will be quite pleasantly surprised by the outcome.
Yeah. So, all right. Well, Tim, thank you.
Of course.
I appreciate it, jumping on, doing some demo action. So, and everybody, thank you so much for joining us today. I know there's a post-session survey and whatnot. Please do take that. We take these things seriously. We have a whole bunch of stuff that's going on over the next couple of weeks in terms of live streams and a bunch of different topics going on. So stay tuned for more things there. You get I think JP put a link to what else is going on in some of our tech talks. So I hope this was valuable to everybody. This is kind of a little, it's definitely a high level, nice kind of intro overview of some of the special nature of, Cockroach. So I hope it was valuable. So Tim, thank you.
Indeed. Thank you.
And I hope to see you next week. So, and
See ya.
maybe I'll see other people at shows somewhere in the